Good morning, students. Today we will start dipole induced dipole forces. On that day we have completed the dipole or Kissom forces. Okay, so in this one I have told to you about the orientation effect and what is the Kissom forces, means attraction is there. Now today we will start the dipole induced dipole forces. So in this one what will happen? This type of attractive forces operate between polar molecules having permanent dipole and the molecules having no permanent dipole. In this one, permanent dipole is also present and non-permanent dipole is also present. Let's see an example here. The molecules of a substance are non-polar, okay, such as noble gases, iodine molecules, they do not possess any dipole. So these are the noble gases which do not produce any dipole. When these molecules come into the neighborhood, means when they come in contact with the second one of the molecules, the permanent dipole or induced dipole is appear. Okay, on that non-polar molecules, where they will produce on a non-polar molecules. These are the diagrams you can see in a figure 4. You have to make the diagram like this. Now why it is so? It is formed on the non-polar molecules. Why it is? Because the electron cloud of the non-polar atoms or molecules get deformed due to electric field, because they will deform to each other and form an electric field in the polar molecules. First of all, they were formed in the non-polar molecules. When they were converted into the polar molecules, what will happen? They deform to each other. When they will deform to each other, what will happen? There is shift in the center of the gravity of the negative charge. Means when they will formed and they will shift to the negative charge. When they will shift to the negative charge, the formation of induced dipole moment is produced. Okay, as the size of the atom increases, as the size, very important it is, as the size is increases, then electric dipole is also increases. And these are the diagrams. Make it. First of all, they will form in a non-polar molecules. When they will convert into the polar molecules, they will go to the negative side. When they will go on negative charge, then what will happen? The result formation, induced dipole moment is produced. Induced dipole moment is produced. What they formed? They increase the size of the atom. When the size of the atom is increased or the molecule size is increased, then electric dipole moment is also increased. Fine. Then the interaction energy is also proportional to 1 by R6 and depends upon the dipole moment of the polar molecules and polarizability of the non-polar atom or molecules. Okay. After this effect was studied by the Debye in 1922, which is known as induction effect. Next is the hydrogen bond. Hydrogen bond also I have explained yesterday. In a hydrogen bond, this is a weak bond which is done between the fluorine and the hydrogen. Okay, so attraction may takes place when hydrogen bonded to atom or highly electronegative elements such as fluorine, oxygen or nitrogen. The hydrogen atom forms a weak bond with the electronegative atom of the other molecules. Means here they forming a this bond is forming, this is the weak bond they are forming between the two, between the fluorine or between the oxygen or nitrogen. Okay, so in other words, what we can say, they form a bridge between the two atoms. They form a bridge between the two atoms, bonding one atom by a covalent bond and other by the hydrogen bond. One may form with a covalent bond and second may form with the hydrogen bond. Understood till here? And the energy of the hydrogen bond is varies from 10 to 100 kilojoules mole inverse. Okay, till here understood to all? Next, after this we will start the thermal energy. In a thermal, you can see this one also in iron dipole forces, but van der Waals forces are not in use. So beta, please write down these things in your copy. Okay, thermal energy is not more important, but only the definition you can write down. The thermal energy, by the thermal you can know that a heat word is coming here. Okay, the thermal energy is the energy of a body due to motion or movement of its atoms or molecules. Means it is the energy from the body, from where it is coming between the motion and the movement of its atoms or the molecules. From the atoms and molecules it is coming. Fine. Next, we will start the intermolecular forces versus with thermal energy. So here various differences are there of solid, liquids and gases. So you can see here The three states of matter arises due to competition between molecular interaction energy, which keeps molecules together, and the thermal energy, which moves the molecules apart. The competition between molecular interaction energy and thermal energy determine whether a given substance under given condition is a gas or a liquid or a solid. Means by the thermal energy we should know it is a solid or it is a liquid or it is a gas. So in a solid, in a gases, they are saying they are the weakest molecular interaction. There is no attractive force. The molecules in gases can move at random in all directions. You know very well they will move in all direction. Now you can see here they are the weakest, but here they are the strongest. Why they are the strongest? Because they remain on a one place. In solids have no translatory motion and can only oscillate with respect to equilibrium position. What about the liquid? Two types of energies are intermediate between solids and the gases. The net force between the molecules are attractive forces. In this one, when the molecules are forced to come very close, the force becomes repulsive. Heating, the thermal motion increase and solid melts. What about in the liquid state? There is a balance between attractive intermolecular forces and thermal motion. Solid and liquid cannot be easily compressed, but gases can easily be compressed, which we have studied in 9th also. Okay, after this, let's see this flow chart here about their compressibility. You can see here compressibility of gases, solids. What about the molecular interaction of energy? Gases having gases, liquids, and solid. Means when we will go from the left to right, it may increase the molecular interaction. Now thermal energy, when we will go from right to left, it increases in a gas. First of all weak in solid, then liquid, and then in gases. Now types of bonding and melting of boiling point. This we have studied in 9th also, melting and boiling point. Now ice is changed into water with the help of the heat. Water is changed into the steam with the help of the heat. Again this steam is changed into the water by cooling. Water is changed into the ice or solid by the cooling. So here what is the melting point? When a solid is heated, it melts to form a liquid. The temperature at which a solid melts to become liquid is called as melting point. Means solid melt to form a liquid. When it will melt? When the temperature is low, then only it will melt. Okay, sorry, when the temperature is high. Heating a liquid change to vapor, the temperature at which a liquid changes to vapor is known as the boiling point. Fine. After this, please write down beta these all things in a copy, so I can't say again and again that you can write down. So here various characteristics are there. You can the things what you like you can write down. Here characteristics of gases, shape and volume is there. Compressibility is there. You know about the compressibility, compress nicely. Homogeneous nature is there. Density is there. They having a low density. Pressure is there. Pressure equally in all direction. Liquefaction is there by cooling and supplying pressure. Diffusion is there. Gases intermix readily and completely in all proportion without any mechanical aid. Better now liquefaction. When we are compressing the gas, when we are compressing the more and more gas, when we are compressing, the gas may change into the liquid as we are filling the cylinder. When we are more compressing of it, this gas we can't see, but this gas is when it go under of it in the cylinder. Not only LPG cylinder, in other cylinders also I am telling, it may change into the liquid automatically. That is said to be the liquefaction by cooling and applying pressure. So measurement in mass. The measurement in mass is done by the weight of the container containing the gas minus weight of the container after removing all gas. Unit it is SI unit, kg, 1 kg 10 to the power 3 grams. So what will happen? Number of moles is equals to mass in grams upon molar mass. Measurement in volume. The volume of a substance, the space occupied by it. Unit is 1 ml is equals to 1 centimeter cube. 1 liter is equals to 10 to the power 3 centimeter cube or decimeter. Okay. Measurement by volume is over. After this, measurement in pressure. Measurement in pressure is force per unit area. Pressure is equals to force per unit area it is. So gases exert uniform pressure in all directions on the walls of the container. in which they are confined. Thus, the pressure of the gas is a force exerted by the gas per unit area of the walls of the container. Understood? So now next we will start the units of atmospheric pressure. Mercury is used as a liquid in barometer. This please learn it, these things. Unit of atmospheric pressure. Pressure is equals to force upon area. When we find out the force here, then what will happen? Force we can say as mass into acceleration. We have studied in the physics. So now force is coming this one. We will put this value on this one side. P is equals to mass into acceleration upon area. So here we can say as mg upon a, where m is the mass of the mercury and g is the acceleration due to gravity, and d is the density of the mercury. The mass is given as, now see here what is the mass. M is equals to d into v. Okay, d into v. V is the volume and d is the density. So what will happen? Substituting the value of m, this m value is expressed in P. Now this value we have to put here. P is equals to d into V. Mass is this one. In a mass side, d into V. Acceleration is g. G is here. Area is A. So volume is equals to area into height. Area means A into H. P is equals to, now listen it very carefully. V, how much? A into H. So D come here. A into H means this V1 portion is come as A into H into G upon A. Okay, after this what will happen? H, D, G, A and A will cut it. It form as P is equals to DHG. Here 1 atmospheric pressure is equals to 76 centimeter of mercury, or 760 mm of mercury, or 760 torr. SI unit is said to be this one. Okay, understood? Same as we will studied about the, you can do by yourself this one, measurement in temperature. Okay, measurement of pressure is over. Now I will start. Next is gas laws, which is very important. Okay, gas law, what they are saying in a gas law, Boyles law is there, Charles law is there. Okay, so in a gas law, first of all, the volume of a gas depend upon the amount of gas, pressure and temperature. From the study of the behavior of the gases, certain generalizations were made. These generalizations are called as gas law. So first is Boyle's law. In 1662, Robert Boyle, what they have said, now you can see here. At constant temperature, means temperature is remain constant, the volume of a fixed amount of gas is inversely proportional to its pressure. Temperature is remain constant, but the volume is inversely proportional to the pressure. Means we are talking about the two things. One is the volume and second is the pressure. So mathematically, volume is inversely proportional to the pressure. Volume is equals to K1 upon P. Why proportionality sign this is? V is the volume, P is the pressure, K1 is the constant proportionality. On rearrange, we can write PV, this one PV is equals to K1. It means that constant temperature, product of pressure and volume of a fixed amount of a gas is constant. Okay, so we can say here P1 upon P2 is equals to V2 upon V1. From here it is coming. So Boyle's law can be say that the product of the pressure and the volume of a given mass of a gas at constant temperature is constant. So this is about the Boyle's law. Understood about the Boyle's law? These are the graphs which you can write down in your copy. Make it in your copy. Okay, these are the graphs. Fine. About the Boyle's law. Next, after the Boyle's law, we will do some numericals here. First numerical is this one. A gas occupies 200 ml of a pressure of this much bar at this temperature. How much volume? So P1 is given here as 0.820. V1 is given here 200 ml. V2 we have to find out. Okay na? Please don't be confused because they are asking about the volume. So V2 we have to find out. and P2 is given as 1.025. This is P2. Okay, P1 is this one and P2 is this one, and the wall temperature is this one and volume is this one. So volume 2 we have to find out. We will put the formula here, V2 put on one side, we will put the value, then the answer will come. In all these things it may be like this only. Please write down these all things in your copy. You can see it nicely. Okay, means you have to see this thing, what the thing is given in the question, that thing you have to write down first. Okay, then you have to find out that V1 we have to find out, or V2 or P1 or P2. Okay, like this 120 ml is given here, that is V1 here. Okay, 35 temperature it is, 1.2 bar it means it is a pressure. The gas 35 degree it means again it is a temperature too. Now they are asking about the pressure. So P1 we got it, V1 we got it, P2 we not got it. Same pattern we are using here. P2 answer, pressure is coming in the bar and the volume is coming in a liter or ml. So these things you can write down in your copy. Next turn we will start the Charles law. Okay, thank you students and have a nice day.